audio is fine and you hear me okay. I'm going to double check that this is actually what happens. Let's double check everything here on my end. Hopefully we get all good audio, everyone. Yeah, so Yalamir here. As you may know, I am a programmer and musician doing all kinds of cool projects. Yeah, let's see if I can go and start a stream on Instagram as well. Usually I'm streaming this on a bunch of different platforms, so let's see if everything is going to work here as it should. Meanwhile, I'm going to say that I'm streaming this usually on multiple different networks, my LinkedIn, YouTube, Facebook. Feel free to comment. I would put other comments on screen so that people from other worlds and networks can see this. Let's see why my see why my Instagram feed is still broken. Thank you for people watching on Facebook and YouTube. Feel free to say hi in the comments. Today we're going to continue a live coding session I did a couple of weeks ago where I did a MIDI mapper library. And we're going to enhance that by adding some more components to this, particular components to do MIDI delay or MIDI echo, whatever you want to call this. So let's see what we're doing here. And how's everyone, by the way? This is, so with me I have here Thea Peterson, who's also a very talented coder and musician, who's going to join me on this hopefully interesting stream. Seems like I cannot make the Instagram stream work today for reasons. I'm not sure why. Okay, we don't need the Instagram link. Let's go. So, oh, maybe I am getting it to work. Okay, good. Great. So we're going live on Instagram now as well. Okay, so let's talk about what we had before and slowly see if we can improve this. So let's bring my screen back. Okay. One of the things that sometimes happen for whatever reason is that, here you go, I just did that, and now my monitor is fixed and does not let me change. Does not let me change my brightness. I'm not sure why. My computer is deciding to kind of act up, but that's what happens. I'm stuck with low brightness now. Funny technical problems they are happening here. I'm going to put this on hold for a second and then fix my technical problems and come back shortly. All right. So let's see what's going on here. Hopefully you can hear me again after the slight technical problems. And let's bring back Thea. And let's bring back my screen. Here we go. Okay. So we're back. We're going to talk about coding a MIDI mapper, a MIDI Echo plugin, and let's show what we did last time. So first of all, just so you know, I'm going to do all this debugging with Plugin Buddy, which is a Modalix free plugin host and plugin that is used specifically for this purpose of using MIDI effects. We just put an update on it. You can get it for free on the Modalix website. Great. So let's talk about what we did last time. There is here a little MIDI effects template plugin. That thing has a few parameters with a few modes that can create all kinds of mapping on the notes. Like one easy one is a transposer. So I'm going to play. I'm just going to hit a C. Oh, I think my internal piano is still open. So I'm going to click a C, and I can just right. I can also do something like harmonize, which would add an interval, right? Or I can do something that adds random notes. It just adds a random note to whatever I'm playing. This is what we did last time. We created a nice library for this, which we're probably gonna kind of review as we're making this. And now what we're going to do is we are going to create a MIDI Echo. So the main thing is for MIDI Echo is there's actually a few different things when we're thinking about how to approach this problem. So one way is we can and we will probably start with that. We can just take something that kind of keeps track of when the original note was played, and then triggers the real note sometimes after. This is going to be the first thing we're going to do. So there's going to be some state keeping. This, because we get a call for process block in a plugin, this call just says here's a buffer, there's some MIDI notes in there, and why don't you process them in some way? But when we're talking about a delay, we actually have to keep the states, because it's very possible that the notes would be outputted in a later buffer. So we cannot just do all these operations like we do with the mapper inside of the buffer. We have to take a note, kind of realize, do some state management, and then later re-trigger it. And in MIDI, that actually leads to some interesting questions, because we don't want to get stuck notes. We don't want to get duplicate notes. So we want to somehow work around these problems and delay the notes. So let's start with the most basic thing. First of all, I am going to switch my screen to full screen, put my face here at the bottom. There's a question on the chat. All kinds of really funny questions. One from vegans from outer space saying, "What the heck?" The question is, we are doing some live coding here. This is the thing. There's someone else called the biggest jerk saying, "Are you guys dating?" And the answer is no. We are not dating. Thea is on the East Coast doing her thing. I am on the West Coast doing my thing. But we are working on projects together. And we decided to do the stream because Thea has a project that might require some of these components. And we thought it might be cool to have her involved in the discussion of what this library would contain. Yes. So let's continue talking about this. Feel free to write comments in the chat. For some reason, I don't have the ability to bring up Instagram comments. I can only read them out loud. But if you're on YouTube or on LinkedIn or something, you can have comments there, and I can bring those on screen so we can discuss them. Okay, let's get this happening now. So I'm going to first create another like plugin similar to this thing. Before I create this, I can already see there's a bit of boilerplate here that I probably need to push to some shared location, just so that I would not rewrite it. So it's mainly these two things. These two things do kind of like automatic automatic save and load of parameters. And none of these things actually belong in this demo plugin. By the way, I can see Albert saying mind-blowing. Thank you, Albert. Hopefully this would be interesting. Feel free to check out the GitHub repository in the description, or get Plugin Buddy for free if that helps you. Sanjay saying, "Oh my God, hey, finally caught one of these." That's awesome. We're trying to be spontaneous about it and do it whenever there is something useful for us to talk about during the stream. Okay. So when we got this, the first thing I'm going to do before I'm going to write this new plugin is I'm going to go to this processor base, and I'm just going to just put these as just like I'm going to just have the contents of this functions as a part of the base class, just because. Oh, you know what? Maybe I'll put this as a free function. Maybe this would be a bit better. So I have this thing called Sure Plugin Helpers, and I'm just going to let's where was I? Where's the plugin processor? Let's make a helper function for this, something like void save. What is the? So this is something with a similar signature to what's used by the Juice plugin processor, but I'm just going to create it as a free function. So it's going to look kind of like this, but let's call it I don't know, save plugin params, and this is going to have the const Juice audio processor, and the data. And this, I'm just doing all this stuff because I don't like to have, you know, things just duplicating something that is completely generic, like saving the state, because we would need state saving in this new project as well. So get state is save, and we're going to go to helpers, processor.get name, save param tree processor. So this would be the implementation of this function. And then I'm just going to call it plugin helpers, save plugin params, and pass in this. And then in the same way, I'm going to do load. So load would be here. Let's see what the signature of this function should be, because I want to be generally compatible with the way it works. So the question is this your base starter project setup? Yes. This whole project is just based on the Juice CMake repo prototype that is a public repository on my GitHub. I know a lot of people are using it as, you know, a starter project to start new Juice projects. So it's using all of that. And one of the things that it has already is this thing called processor base, right? And this is just a base class to save a lot of like boring boilerplates, because there's a lot of boilerplate to do when starting a Juice project. And I don't like, you know, repeating stuff and having all these like error prone virtual method overrides. So I like to have this contained. And whenever I get to a situation like I am now, when I'm writing the same thing over and over, like I know load and save the parameters or something. I forgot to copy the signature of the function. Yeah, so this is generally what I'm doing, and I'm always trying to like capture patterns whenever I can, so that I don't rewrite the same patterns, especially if I can just make them, you know, free functions or something that is you know, something that the plugin can choose if to use or not. So this is going to be like save oh, did I delete the previous one? What just happened? Yeah, so I need something like this is going to be something like load plugin params, and I am going to pass the processor in there. This can have the processor. Yes. And let's put this in the CVP file. And now all the example project is going to have is it just going to have a call to plugin helpers, load plugin params, this data size, right? And this is good because now if you were looking at this this plugin project, it only has what's needed in the you know, to actually talk about what's important here, which is the parameters. So there's only just a couple of functions: get states, save state, set state, and get state information, and the process block implementation, which is more specific to what this plugin actually does. I can also make these private. This is nice. Okay, good. So I'm going to just see that this compiles, and then we're going to make the new plugin for MIDI delay and start to work on that. Okay, it's good. Compiles. Oh, let's see that it saves and loads just for fun. Let's load this. Let's change something like choose, you know, random, and change a bunch of parameters. Let's close. Let's load it back. And those parameters have all been saved. So it's good. It saves and loads the presets. It does it with as little boilerplate as possible. And we can probably just move on. Okay, let's save this. Let's call this. And you know what? Just for good measure, because I'm OCD about these kind of things, I might even copy this stuff into the base class, because why won't this be the default? So let's just take these two implementations, go to processor base, and these would be now processor base, and then just include the helpers here. And that means that I can literally just remove these from this processor, and I should still get this behavior for free as long as I only have parameters. Then if I have something other than parameters, I can just choose to implement something specific. Seems to compile.
So on top of what we have, we're implementing what? Live MIDI delay?
Yes, and I feel like they're both going to be pretty separate components, even though you can use them together, which we would also try. So let's do this processor base.
So live MIDI delay and tempo synced? Or
edit saving of the parameters state to the base class to avoid duplication in the examples. That's great. Okay, so we got this. We have this ready. Now let's go to create our next MIDI template plugin. So this one is going to be called, let's call it MIDI delay. So it needs CMake. So add subdirectory MIDI delay, and let's give it a better name, like MIDI delay. Company name, let's call it a better name than my company. Let's call it Namir Tutorials or something, because plugin manufacturer is EAT. EATU. Let's call this MIDI delay. MIDI delay. MIDI delay. And while I'm here, let's also use the same information in the other plugins so that we are somewhat compatible. So let's call this manufacturer code. Let's don't call it MIDI effects template. Let's call it MIDI mapper demo. Tutorials. Good. Okay. Oh, it doesn't like a company with multiple this. Let's call this Yalamir tutorials or something. I can find a way to fix this, but I don't care as much. Okay, I got this. Let's build the MIDI delay VST3 and let's have it debug with Plugin Buddy. So Plugin Buddy is in my applications folder. Plugin Buddy, where'd you go? Plugin Buddy, contents, macOS. Here we go. By the way, thank you for everyone joining on YouTube here. I can see a bunch of people watching. Feel free to leave a comment or questions. I'll put whatever I can on screen. I know some people are also watching on Twitch or LinkedIn. Feel free to comment, and I would try to answer. Oh, here you go. We have a VIP comment actually. So this is a comment from John Lamcool. John Lamcool, for those who don't know, is the amazing creator of Unify, which is probably the most advanced, standalone plugin host out there. But he's also the best plugin preset creator in history, who has created some of the best sounds for hardware synth, virtual synth, all kinds of plugins. He has, like, if you own a plugin, it's very likely that the best presets are made by John. And he's also an amazing designer who makes sample libraries and sound libraries and plugin patches, and of course Unify, which is like I said, quite an amazing standalone and plugin that can host other plugins and create these layers of plugins. It's pretty beautiful, and you should check it out. I'm so happy to have John here in the stream. John is awesome. Okay, so somebody says I'm in software engineering, but I don't have a clue what is happening here. Okay, okay. I guess a bit of context needs to be said here. So here's the gist of what is happening. I am generally creating all kinds of audio software, audio plugins, music software, etc. Like you can see with my company Modelix or with other companies that I work for. In this particular case, we are talking about this public repository that I have to create MIDI effects. So they're creating, their libraries that take a chunk of MIDI, notes, etc., and do something with them, processing them. The base one we've just started we started in the previous stream, is something that lets you map notes to other notes. Like you play a note and maybe you wanted to generate a chord, or you want to generate a random counterpoint or something like that. So here we're also gonna start adding the element of timing. So this MIDI library can also delay the notes by a certain amount. So John is saying thank you. Of course, you do incredible things. I'm always looking forward to see what you're gonna come up with. For those who don't know, Unify 2, I think, came out pretty recently. So absolutely check that out. It's pretty incredible piece of work that is very useful. First of all, because it comes with all these amazing patches and sounds that John made, but also it's something that lets you, play without a DAW, and even in the DAW chain all these plugins together, and it's got plugins built in. It's just incredible piece of work. Albert is asking, is she coding too? Thea, do you have an answer?
Okay, so this is actually for my client project. So the part of the requirements include live MIDI delay and tempo sync delay and clock support. And I actually already wrote a MIDI mapper. I cannot show the code because it's for my client, but then I'll argue that I didn't do it in an optimized way. So we started like debating like what's the optimal solution, like how would you do it, how your architecture would be. So this is how we started. So I'm not going to show my project. It's for my client, but AL is going to show me how he would actually structure it so that it's more it's done in a more optimized and maintainable way. So that's the context.
Yes, but also what I was hoping is that some of these tools can actually be reused for all kinds of other contexts. Like for example, the idea of sorry for messing with the try to find the best composition here. But sometimes what happens with a lot of these libraries is that people are just solving the same problems over and over, and some of these can just be generic. So that's why we're making this little component of MIDI open source. It might not solve every situation that you need out there, but it might solve a few of them, and it might be useful to to just be able to throw something like that out, even just for a reference. If you're coding a plugin, you want to see, well, I just want to see if maybe even if you want to write a better MIDI delay than my MIDI delay, I think it would be good to have a centralized solution that's not connected to a very complicated plugin. It's not connected. This should be very easy to extract and to make something different for your use case.
So could you please feel free to criticize what was wrong with mine to begin with, so to give it a context. You've seen my mess.
Yeah. So it's hard to describe something that people have not seen. But what was happening in your previous project, from what I remember, is you had the MIDI mapping logic kind of connected to the delay logic. They were almost like the same component. And what I was suggesting when I saw it, I said, well, those are two separate operations. You can have both, map and delay, but they can be totally separate. And if you separate them, I think it can lead to better control over each of the components. And we're also going to talk about specific features and problems that are a part of this domain. What it means to do MIDI delay or MIDI effects, but I'm just thinking it's going to help centralize a lot of these problems, hopefully reduce bugs, and also make this more durable, and would also implement things we're about to talk about, like host quantize and other similar things.
So we're doing two different ways to do it, right?
Yes, we're going to talk about all the host features in a bit. I want to start with something very simple, and then we're going to build up on top of that very quickly. Okay. There's another question here from Twin Pix. Can I make this? Can I have a background here? I'm just wondering on like the design of this. But anyway, this says, I used to program a Mario theme on system speaker back in my uni days and had a problem with playing two notes at the same time. So it might be helpful in some way to watch your streams. Yes, and this is a classic problem in MIDI programming. And a lot of these older games had to use MIDI because there is just no way to put audio files in like the Nintendo systems or something like that. It's too big, right? Those cartridges, whatever you had in the Nintendo Game Boy or Super Nintendo, whatever systems, they had a very small amount of memory. So usually you didn't have the actual recording of the audio theme there, but instead you had some code for a basic synthesizer. Sometimes it would be a part of the hardware, and then you just had MIDI with instructions. And one of the things I love, there's an old game called Prince of Persia that I love, the classic game, and the guy that made it, Jordan, I'm blanking out on his last name, he talks about the fact that they had for the original version, they had to thin out a lot of the voices because of the limitations of the synth of the Apple II and those older systems that it was written for. And we have, similar problems, and even in professional environments, because even though we're not limited necessarily by, the memory or something like that, we still need some correctness. Like, for example, if you talk about note instructions going to a synth, we have to make sure those notes are correct. Like we talked about this in the MIDI mapper. We don't want to send double notes on of the same note to a synthesizer, because the synthesizer might not know how to handle that thing. Synthesizers are more used to having, somebody playing on a keyboard. But if an algorithm generated random notes, there might be the same note multiple times, and a synth that is originally designed for a player to play might not be able to handle this correctly, and you will be left with, stuck notes or all kinds of other artifacts. And we are going to run into those problems when writing the MIDI delay as well. Okay. All right. So hopefully everyone are doing good. I'm really happy to see a lot of people on my YouTube and Facebook and all that kind of joining in. All right. So let's go back to coding here. Oh, so what first I'm going to do is I'm just going to rescan the plugins here in Plugin Buddy. And I have here Alamir Tutorials MIDI Delay. It's going to crash because there is a problem with one of the tag names here that says MIDI delay. So there's a problem because my my little function that says save plugin parameters. Oh, here it is, processor get name. So I need to probably fix that in case the name has a space in it. So let's do something like string get fixed plugin name juice string const juice string. I could just pass the audio processor, I guess. Juice audio processor turn processor dot get name, replace characters space with underscore.
Could you make the editor bigger? Me.
Oh yeah.
Thank you.
Sorry about that. Here it is. So what ended up happening was I was, because I reused this code for saving presets, that code kind of looks at the plugin name like this, and instead of, and what we had to do, what I want to do instead, I want to fix it. So get fixed plugin name processor, so that I will have something with underscore instead of the actual plugin name there. So let's run this. Let's see that it's fine. And I can have the MIDI delay. Let's look at this beautiful MIDI. It's now this whole MIDI delay thing is just a copy paste of the previous plugin, so there's nothing in there. Good, it works. Let's remove some stuff here because we definitely don't need most of the stuff. We definitely don't need all these parameters, and we definitely don't need the contents of this process block. Good. So we have a totally clean plugin, and then we can start putting some actual contents in it. Great. Done that. Let's commit. Added MIDI delay example. Okay, that's good. Now let's start writing the actual MIDI delay. So I'm going to start a new file inside of my module. Oh, the comment says, that's funny to hear about the OG Prince of Persia music effects. I love how they used to have actual recorded vids as animation for characters, as moves, jumps. Yeah, and you know, I don't think they actually have the videos inside of the game. I've seen videos about it, not an expert or anything, but I think what they did was he recorded the videos, but then he kind of extracted the shape of the image in every frame to create an animation. It's really beautiful the way it was done back in the day. All right, so let's call this something like MIDI. Let's call this delay. Good. Let's include the common. Let's make this header also a part of the module. I think I already have a MIDI here, something like EA MIDI. And let's do something like a struct delay. And the way this delay is going to work, generally speaking, is that it is going to, we're going to have a process function. It's going to say like void process. It's going to take MIDI buffer for the input, right? But we can actually also use it the same for the input and output. And it's going to take every note in the buffer and delay it. That's basically the way it's going to work. So one thing I'm going to do here is I'm going to have a MIDI buffer called something like a temp buffer. I'll explain in a second why this is needed, but I've done something like that, if I remember correctly, in here, right? There's an output buffer. If I look at the mapper, because what we want is we want to first operate on this. Let's call it output as well. So we want to first operate on the output. And then we want to kind of copy everything from the output back into the input. We can call this input. And for now, let's start with the most basic way to do a delay, as I'm going to have sample delay. That's not, by the way, the perfect way to do this, but we're going to start with this just because this would be the easiest way to hear something. So we have the delay, and here's what the delay is going to look like. I am going to create a vector. This is an EA vector for my library, but it's similar to StudVector. It's actually using StudVector internally. And this is going to have a vector of juice MIDI message. No, I'm not going to do a MIDI message. I'm going to do something like that. I'm going to create something called a delayed message. It's going to have a MIDI message in it, and it's going to have let's call this int sample time. This is going to be bad, but I'm going to do this just for the sake of getting something to work really quickly. So sample time is when this is to be played. Okay. So the idea is that whenever we're pushing a delayed message, we're pushing a messages, and we're also pushing when it's going to be triggered. When do you want it triggered? Hey JB, JBMM5FF, thank you for joining us. Coding FL Studio up in here, I see. Well, yes, you could say it like this. This is one of these things that would exist in a DAW, or probably do exist in FL Studio and some of the other DAWs, but they're actually, when in the context of what we're a lot of the times doing, like if you look at plugins that I'm creating, like Eon ARP, Beat Scholar, sometimes you have to kind of encode that functionality in a custom plugin, because you don't just do a delay, but you delay inside of a harmonizer, inside of a sequencer, inside of an arpeggiator. So you kind of need that in the context of something more, more fine-grained than what a DAW would do. But yes, this would, and this technically could run inside of FL Studio or inside of Cubase or Ableton Live. Okay, so we have the delayed message, and we have the vector of delayed messages. The other thing we have to make sure is we have to reserve some memory here, because we don't want each time a message comes in to allocate memory. So let's reserve, I don't know, like 10,000 messages here. This would avoid allocation. Good. So here's what we're going to do. First, we're going to process the input buffer, and then we're just going to push notes into the into this delayed message buffer, and then later we're going to find out if it's actually time to send those messages out. So to do that, we have to find out where we are. One way to know where we are, and this is going to be a very basic way to do this, is we need something like an int sample position. This isn't the best way to do this, but this would be a good start. So the sample position is 0. And then what we're going to do is I'm also going to pass int num samples to this process block. This is going to be useful. Okay, so we do that, and here's what we're going to do. First of all, we're going to go over inputs, and we're going to say message equals m.getMessage. And we also, a message also comes in both with the MIDI message and a position, a sample position of when it was played, because a MIDI message is played somewhere inside of the buffer. That would be something like m.sample position. So let's, when we got this, we can now create a delayed message. So delayed equals delayed message. The delayed message would be this message, right? And the sample time would be the sample position of where we are at the start of the buffer. Am I correct in this? Is it going to be where we are at the start of the buffer? Yes. So the start of the buffer plus m.sample position. I believe this is correct. Now we're finished with this, and we can go messages.pushback delayed. So I'm just creating this, and I'm pushing this into the messages buffer. And it's actually possible that if it's plus sample position, but we also want to add the delay. So let's add the sample delay. And this is actually important because the sample delay could actually be 0. 0 would actually mean that we're going to trigger this just as it was played. We also want to kind of maybe want to make sure that this never goes below 0, because that could create weird things by setting this into the past. But the setting this into the future should work. So we're going over all these input notes. Now we're going to see when is it time to take these notes that we delayed in the past and push them out into the output buffer. So here's what we're going to do. I just realized if we do this, we might actually not need the yeah, so I think we actually don't need the output buffer in this case. We can even get rid of without that. We can just, after we finish with this, we can just take the input, clear it, and now we can see what we're doing. So what we're going to do is, for every message, every sample, and we can, by the way, do this in a more efficient way, but I'm just going to start with this for simplicity. So for every sample, we are going to go over the entire vector of messages. And if a message is to be played, we're just going to ship it out. So for O2, and there's a better way to do this, but I'm really want to simplify this whole flow for now. O2 messages, not sample pause here. This is times number of samples. Our current position is sample pause plus sample, because the sample pause, it's the sample position at the beginning of the buffer. Alternatively, we can just do yeah, so we can also just do just started with sample pause, number of samples plus sample pause, right? That's another way to do this. So if plus yeah, we can actually just do, no, I don't like to do this. I think it's going to be clearer if I just do a regular for loop here. And when I finish, I just do plus sample pause. So here's what I'm going to do. I can, for every message, I can say if message dot sample time is less or equals to sample pause, then we're going to dispatch it, right? So to dispatch it, we can just go and input dot add message add event. It's going to add the message dot sample time. Sorry, the message, just a message, and then the timing is the current sample in this buffer. It's message.message or something. And this is it. Now, the only thing we have to do also is we want to make sure that we don't re-trigger this in the next sample. So let's do something like a bool triggered. It's a simple way to do this. So when I'm finishing with this, I can also do message.triggered equals true. And here, so if the message is not triggered, right? So don't double check it. Then after we're finished with this for loop, we can just remove everything that is that has been triggered. So we can go and do something like messages dot erase if. It's a nice helper function that I have in my vector. It's a combination of a couple of functions. So move equals we need to m, and this would be remove return m triggered. So that is the remove function, and we can just pass it. So we have a function that's going to remove all the MIDI messages that have already been triggered. This is basically what this does. And then we're going to increase sample position. So I think this is the general logic of how this would work, even though this is very raw. Like this does not do a lot of the things that a MIDI delay would do. But I'm also kind of like ignoring, you know, controllers. I'm just doing things very, very blindly here. But we're going to see what happens. We're going to start processing with this.
Okay, just to clarify, you're using absolute sample times and you're queuing them, right?
They're not absolute. Yes, they are. They're absolute compared to like a clock that keeps moving. Yes. So what happens now is that every sample, like of this block, I'm going to increase the sample position.
So you're using a running sample position counter across.
Yes, exactly. Which isn't the best way to do this. So that's what I'm saying. This is a very simplified solution. It's very likely that I'm going to switch this to using a musical time, using PPQ very, very quickly. I'm just starting with a sample position just because this will be a way for us to get something playing right now. But I'm going to switch this mechanism very quickly and use a PPQ delay or something like that. But this should be good enough, I believe. I didn't double check every line of code that I did here, but I think this is should kind of work. So yeah, by the way, this is not the most effective, most efficient way to do this, but we'll see. So let's go now to our plugin. And what I'm going to do here is I'm going to instantiate something called EA MIDI delay. And I'm also going to have a parameter here that says the delay, just so that I can test what I'm doing. So let's call this delay param, new param int. Let's call this delay 1. 1 is the version. The minimum is 0 because 0 is also fine, but we also want a maximum of, let's do something like 100,000. This is in samples, by the way, which is not good, but we're gonna fix that very shortly. The default would be 0, and then let's add this parameter. Oh, this is still called MIDI effects processor. Let's call this like a delay processor. So add parameter delay param, and the process would be something like delay dot process MIDI messages. I am going to use this buffer because I need the number of samples from it. So the samples would be delay param dot get. This is the number of samples the user would put in, and the number of samples would be buffer dot get number of samples. So that's basically would be our plugin that calls this utility. And let's see if this does something that we like. Thank you, Mark. I'm happy that people are enjoying this. I said feel free to ask questions or comment. There's a comment on Instagram that says absolute trauma from Twisted Joy. I don't know what the trauma is, but who knows?
What's going on?
People are traumatizing by code. They're traumatized by MIDI. I have no idea. Could be anything.
Okay.
Okay. Here we go. Now this is 0, so it's playing away. And let's add. So now this actually delayed, but you couldn't. So we need to add a little other utility here just for the sake of understanding what this did. The utility that I'm going to create is going to be called, let's call this, I want to do something called like a dry. It's almost like a dry wet mixer. Let's call it. What would be a good name to do this? Let's call this duplicator. All this duplicator would do is it's gonna take the original MIDI that we sent into it. So I'm going to call this something like store. And this would do something like, I think I already have a function for this, so it's something like should have a helper function that says, do I not have that? I just have replace contents with. Okay, so I also need a copy function. Let's do this something like this. Copy buffers from a const MIDI buffer source into a MIDI buffer destination. and this is going to take the destination and clear it, and then go over the messages into source and go to the destination, add event, get message, sample position. So pretty useful utility function. So all this thing is going to do in the store thing is that it's going to copy. It's going to be something like output dot. Need to include this. Include helpers. Copy buffers from the input to the output, and then let's call it load, or let's call it mix. Mix would be good. Mix. Do I have already a function that says mix here? I just have replace, right? But I also need something that adds. So let's call it mix buffers. And mix buffers so I can actually just have those reused. So this would just be the mix buffers. Just copy from one source to the destination. And then copy buffers is just going to be mix buffers source tests. So they're going to use, these functions are going to use each other. Okay, so when I want to finish this is just going to do mix buffers. Let's call this storage to be a better name. Storage. So copy from storage to outputs. So this is just what it is. Just the duplicator, just something that we can start by storing. It handles this other buffer, and in our plugin, we can do something like EA MIDI duplicator. And when we start, we're going to do duplicator store, right? Do all this processing, and then duplicator mix. So I just did that so that we can blend the original and see what this thing did. And this, by the way, might also expose a few bugs that we have to deal with. So
just to clarify things, the store copies the original MIDI and mix re-adds it.
Yes. So now let's add a delay here. See what happened? You hear both the original and the delay. Let's have longer delay. Let's have a shorter delay. Kind of a cool plugin, right? Pretty cool. Am I not correct? Is it not cool? I'm just playing single notes here, right? If I'm going to have 0, and with delay, it's going to be pretty nice, right? Okay. So we're in a good start, right, Thea? This is a good start for a MIDI delay.
Yes, right now the output is relative to the input. It's not quantized, right?
Right. This is just relative. We're going to start simple. But also it's not quantized to any kind of like musical time as well. So we have to do that as well. But we haven't done that too. It's all we're very. I only wanted to do something where we kind of in a modular way, both delay and hear the original if you wanted to. There's another thing we're not handling here, which we probably should. And which is what happens with sorry, here it is. So this is a great feature that somebody's asking. So time to make an array of duplicators with decreasing velocities. I love this. Okay, so this is now getting cool in the cool world. When we're saying let's not just have one feedback, right? Let's have multiple feedbacks and make it act more like a real delay. Da, 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 right? Something like
But
that.
then the behavior that we wanted was just, the thing that we talked about, quantized.
Well, we could look at we could. It's possible we can actually do both because we can actually. Well, let's talk about this. This is actually such a cool feature that we probably want to talk about it. Basically, how to implement feedback, right? Um, but I'm going to start just by committing this, so just so that we have something committed in our repository. So added initial MIDI sample delay and duplicator. Awesome. Okay, so this is pretty basic, right? We started with this. This just delays the thing. One of the things that again is also very important, in a lot of these delay effects, is just like Sanjog. How do you say Sanjogs? I don't know how to pronounce this. Is saying is that what many times you want to do is you want to continue processing this to make the sound good, right? Because MIDI delays usually have, or audio delays have this effect of continuing to filter, not just like tape. Ooh, there? Am I still there?
You're kind of freezing.
Just checking that the world is not collapsing.
Now you're back.
I'm back.
Mm-hmm.
Okay. Um, okay. We drink some water, and we can move forward. Okay, very good. So this was just this was a basic way to do this, and we can think of what would it look if we wanted to continue processing each of them. For example, one of the things we could do is we can say, well, one simple way to do this is that we can apply processing to a note when we bring it back, and then we can also pass like a boolean that says, hey, do you want to keep triggering this? So that's one way to do this. So one fun way, we can do something like I'm just gonna very quickly write a feature, write this feature so that we can do this. So let's do something like let's think about this. Yeah. So one way to implement this let's call it feedback feature is we can work with it as if it's like a regular delay buffer. For example, we can work with a circular buffer here and just push things into the circular buffer basically, and then we should just pull them out later. That's one way to look at this. If we do that, I think for every sample we would need a vector of messages, kind of different than an audio delay, because we would need vectors for every sample. It could work. I can make it work like this. I think another way, think about this. Another way is I can more manually process this. So one way is to do something like yeah, so one way would be, let's do something and call it let's call it processor or something. Let's call it MIDI. delay. Let's call it delay processor. Would be good. And that would be a way to inject that behavior for the notes. So what it would do is we have virtual destructor. I don't know if that's a good name. But then it could do something like bool, let's do something like should delay, virtual bool should delay, turn true. And then I can do something like, think of what would be the best way to do this. Virtual void process, process delayed. And then, yeah, so then if the message triggered and then I can do something like if message dot so let's say there is a processor here. Something like let's say it's get past here, process and it also take a delay processor. And then what I could do is, if the processor should delay message. So that's a way for the like a custom processor to decide. For example, if the we can decide if this is this the best way to do this? I'm not sure, but it's one way to do this, like, because that's the way I can just reduce the velocity until it reaches a certain point. Is this the best way to do this? I'm not sure. Maybe not. Let's wait with this, because this leads to like some interface questions and how to do this generically. But I do want to do this feature. It's gonna be pretty handy.
So was it supposed to store events? Like what was it?
Yeah, like my idea was that mostly the thing I'm trying to think is how to do this from an interface standpoint and not in like a plugin. So the idea is that how am I going to do something that can create feedback, that can continue delay something until, for example, the velocity is below something, or continue processing the velocity each repeat or something like that. That would be very, very useful. That would make it very musical sounding, probably. But let's wait with that for just a second, because one other way we can do this, just for the sake, is we can actually perform like one way to do this is we can perform 5 delays one after the other, each one reducing. Yeah, so that might be even a better way to do this. So just stack up multiple delays. So we need.
But you wanted to inject that behavior, like, and decide which MIDI messages get delayed and how they're handled and how they're emitted and stuff like that. Huh? That's what you wanted.
Yes, but I'm gonna pull back on this, and because there's a couple of things I want to fix before that.
Okay.
But we can totally do that as well. So that's why I'm but what I just realized that we can, and you know what, we we can do this just with one thing. I just realized we don't even need the if. We just need, maybe we do. Maybe it's going to be useful. Yeah, we can do that. So here's an example. I'm going to go back to my exact position before. So I just need should delay and I need process delay. I think that's enough. I think that would be enough. Because that, and then if I do have a processor here, yeah, and I think that's fine. And then what I can do is I can do something like I might need a CVP file for what I'm about to do, because I'm about to create a static default here. Let's add the CVP file. Include MIDI CVP. So the question is anything inheriting from delay processor? Yes, there is something that's going to inherit from delay processor, and I just did not add it, but I am about to add something that inherits from it. So the reason why this is going to be virtual is that the idea is that a plain delay, and sorry for not explaining this before, that is that a plain delay would just be, like the most mechanical delay, like dup, dup. That's all it's going to do. But what Sanjay, I hope I'm saying your name correctly, what Sanjay said before is that, more musical delays, for example, would apply some velocity filtering. So they are going to say, well, for every node that's being delayed, let's reduce the velocity. That's going to be very classic delay function. So what I want is the user of this library to be able to inject a delay that does something for the nodes, like make them louder, make them softer. Another way is, a process delayed could also like mute certain notes. Say, well, if the node is below certain velocity, don't even play it. If it's a controller, ignore it. Something like that. Like there's all kinds of things that you might want to do with the custom delay processor, and I will show a couple of them pretty soon. So those virtual functions are not there for nothing. They're there because we actually need them. So
it's there like as an extension point, so we can like inject different delay behaviors later.
Yes, no. and that later is going to be 5 seconds from now. So it's not long before we'll see the use of this. So this would just do static. And so I'm creating this so that the default behavior would be to use this stateless delay processor. But the user can also pass a custom one. So this is why I'm doing this. But we are going to create a custom one in hopefully a few seconds. Did I add this MIDI delay.cvp? Okay. It's good. Move to CVP. Move this to CVP as well. Why is my Clang format acting up? This is not what it should be doing. It's almost like it's ignoring my Clang format file. Is it not finding my Clang format? Clang format. Okay. Okay, much better. I have my formatting as I like it. Okay, good. And now what we're going to do is that this processor should delay. We're going to start with this. probably don't need this here. I probably need this here. So if, yeah, so delay message. Okay, so if processor should delay, if the processor should delay the function, only then do this. Because otherwise there's just no reason for it. We can just ignore things. For example, we can just say that we only want to delay notes and not controllers, that would be the obvious way of use of this function. The question is, if we're not delaying this, yeah, so if we're not delaying this, the question is, are we filtering it out or are we putting it back where it was? That's another interesting question. Think about this. So I'm seeing the mental challenge of having to think about writing this for use as a library. If it's a solo plugin, things would be a little different. Depends on how modular you want things to be. Exactly. But I'm already kind of foreseeing a few specific use cases. So I'm not. This is not going to solve every problem in the world, but I am foreseeing a few basic use cases, even just for the sake of the demo. So that's why I'm already kind of like maybe complicating this a little bit for the sake of the couple of options, like for example, only filtering notes and other things. But I'm going to start with this for now. Right, so if it's not delayed, it just gets removed. Yeah, I guess it's fine. No, you know what I'm going to do? I'm going to do something else. I'm going to do that if it should delay. Let's do that. This would be a good idea. If it should, if it should delay, then the sample time. So let's do this. The delay sample time should just be by default the sample position plus m.sample position. So by default it's just going to play it as it is when it comes back in. But if it should delay, then it's going to add the sample delay. I think that should be a good way to do this. Otherwise it's just going to play it right now. That's going to be the logic I'm going for with this particular library. And the next thing is, before I'm processing the event, I also want to process it. So I want to do something like once it's time to trigger it, I want to do processor dot process delayed message. And I'm doing this because this is a chance for the processor to make every repeat, for example, softer than the previous one. So and we're going to show an example of that right now. So the example would be here in my plugin processor. So let's create something like a velocity reducer processor, which inherits from a MIDI delay processor. And what it's going to do is process delayed is going to do something like if it's is note on or off, set velocity, get velocity. Is that come to mean as a float? So get float velocity. Get float velocity. Let's do something like to new val equals this minus 0.3, and let's limit it. So new val equals j limit 0 1 new val to make sure we don't do any negative velocity, and then set it. So this is how I'm going to process this, and then I can just have this Novell processor. And when I'm processing, I can pass this velocity processor, and let's see if this worked. So what this should do is it should make every repeat of every note softer than the previous one. Let's see if that worked. Oop, might be on 0 now, right? Let's not have 0. Let's have this. I think this synth might not look at velocity, so let's put some other better synth that has velocity. I think what do I have here that is good? I don't want to use Ivory because it's going to use iLock and throw me away from my debugging setup. So let's take, let's grab another synth in there. What synth do I have that is good? Oh, Whirly. Whirly is good. Okay. Do you hear that? Let's bring the volume a bit up. And I don't know if you hear what happened now. You see the repeat? It's softer. Let's make this longer.
Yeah, it's nice.
Right, this is really musical, right? This is a very musical way to do this. Let's make this amount of velocity be a parameter, right? So let's do something like let's add a parameter. So param float. I also want this as a shortcut. So let's make a parameter called velocity reduction. New param float. Vel reduction. Velocity reduction. And it's going to do something like from 0 to 1. 1 would be 100%, I guess. Default would be 0, or some smaller number or something. Okay. Let's add this parameter to our processor. And then what I'm going to do is my velocity processor is going to be just a bit more dynamic. It's going to do something like float reduction equals whatever, some number. And then just before processing this, I'm going to take my how do I call that thing? Vel processor dot reduction. And let's see if this works. So this would give me a parameter to control this velocity reduction. That's the whole reason why it was good to have something from the outside, because it's not very nice to control this kind of externally from the library and write custom logic. So let's see what this does. This is my plugin. Okay, let's make it now really reduce. Let's make this shorter delay. Now reduce more. But I don't know if you noticed, but this Wurlitzer plugin has a lot of like artifacts to it, like this mechanical artifacts. Let's reduce those. Okay, that's better. It's kind of cool. It's kind of musical, right? It's kind of cool, right? Right, Thea? Is it cool? It's not cool?
Yeah, it's way better than what I had. Okay, so now we had an argument. Now you're proving that this is much better, and I agree.
Well, we
So what
didn't
I
even.
had was very simplistic.
Yeah, and I'm just adding this as an example because we might want to do other things, one thing we could add for this, people something that you can add with this interface is you can add something that pitches up, like add like
Mm-hmm.
add like a I don't know something. So there's all kinds of like cool things you can do, but I'm just going to start in saying added initial way to customize the delay and add velocity impact. So we did this. Now,
So what you did is that you're giving us like a reusable delay core.
yes, and now we also another thing we talked about is doing like multiple repeats of that, right? So let's think of what. So one way to do multiple repeats, which is probably the best way, is that we can actually just run this in a loop, right? Run this in a loop. So this is going to be fun. This is going to be a fun feature to do. For example, because it also would require things we need in the interface. So if you want to have feedback on this, one way would be we could just run this delay, 3 times or something, like delay and then have another delay. Have the output of this other delay through the other one, and then just mix them together. So let's do that. Let's do something. So instead of having, and I also need the other duplicator probably, right? Yeah. So let's see how we're going to do this. Let's do so that the delay and the duplicator and the velocity processor, I guess.
So plugins just inject behavior, and that delay core just stays like it stays sample accurate.
Hopefully the interface is good enough, right? This is you make Juice look so fun. I just got to get past all the setup, and now I'm going to be in C major land. I mean, C major is also great, right? C major is an amazing language, especially if you just want to write DSP. So it's really C major really abstracts all the plugin stuff, all the C++ stuff, and it's just, hey, let's write some pure DSP code. But I think there are a lot of things that if you had wanted to do in in a plugin, like for example, you wanted to do something that interacts with like samples and interacts out with the host and stuff like that. Sometimes you're going to run into limitations of C major, but if you're just writing, a chorus effect or something, I think C major is pretty great. Way more expressive than a lot of these lower language things like Juice. Okay. So just for sake of completion, let's do something like, because this feature I'm going to add now might also cause some interesting problems of stuck notes and stuff that we should also handle probably in this engine. So I am going to call this delay line. I'm going to have one delay line. This is in the plugin. This is just an example. It's going to have this thing like the delay and the duplicator. And this is just going to be something like it's going to process with the MIDI buffer. I think it needs the number of samples, and then it also needs the this velocity processor thingy to be passed in as well. And then what this does is this needs to go for each line. It's going to do this store. I think I also need a delay time because I haven't found a good way to do this. So let's okay, so one way to do this actually is I can, by the way, simplify this and say, do I really want to do this? I need to think of the delay time aspect as well. But just for now, I'm going to do something that I'm probably going to have to change later. But let's just call this, sample delay or something, because that's what I'm expecting in the actual library, which is not good enough, but probably good enough for now. So for each of these lines, I'm creating this. I'm taking this delay process with MIDI buffer, sample delay, num samples, and the processor, and then the duplicator dot mix. So this is just all I did was I just made all this thing as one, because what I want to do is I'm going to create a vector of delay line, calling this lines. Those are basically feedback lines, right? Let's call it feedback lines. I can just make those an array, right? Let's make an array of delay lines, and let's do 8 or something. Let's do 8, and then I take the reduction, and then I can just go and because for each, is that correct? Each of those, I think it's going to be okay. So for let's have a parameter here. Call it feedback. Feedback, let's do 0 or 1 to 8. Default would be 1. Add parameter feedback param. Index 0. Index is smaller than feedback param get. Let's do, just to make sure, num feedbacks, because I want this to be evaluated only once, and this could change. And then process with MIDI message buffer get number of samples. How did that delay param? Let's do delay time equals delay param get. Again, this is an atomic, so I don't want to evaluate this multiple times. And this is the velocity processor. And let's see what we got here. There is a bug that's going to be called here when we change the number of feedbacks, but let's see what's happening. Okay, this is 1. Let's do 5. Let's have more velocity reduction. Let's remove this key up stuff in the Wurlitzer, which I thought that I did, but I forgot to save, I guess. Let's make this faster. What do you think?
Yeah, it's super nice.
This is like a real delay, right?
Yeah. Very different from what I had.
If you make it fast, it sounds really good. It sounds very musical. Right, the more you add velocity reduction, Now, one thing, by the way, I don't love about this is that this particular reduction is doing a minus. I don't love it. Let's multiply this by reduction. I think it's going to work closer to an actual filter. And that means like something like a 0 point, so let's try this again. Okay, and now 100 is strict, but if I do this works more like a filter. This is actually kind of like a cool plugin, right? You can really make music with this.
Yeah, this is actually really nice. I wasn't expecting this.
Let's have a bit more feedback. So there's something interesting that happens here, which we have to talk about. One of the limitations of MIDI in this case is that not every synth can just bring back the same note into its own. So if I'm just going to hold a long note here, wait, so we need to find a way to handle these double triggering things. So this is something that we discussed that I think this library should handle. This is beautiful, right? I'm really happy about this. I might need to release this. This is cool. Okay, I'm hoping you all are enjoying this as much as I do. I am very much enjoying this. Let's commit this because this is fun. So added an example for feedback on the delay usage. Okay, so this is kind of cool. MIDI effect speedrun. That is what this is. This is a speedrun. Come on, this is kind of cool. Okay, and we're going to make this better. We're not done yet. Okay. The one thing I do want to fix here, which is kind of was not always obvious in this with the plugin I was playing, but I think that we also need to have some handling for double notes on and off. I think this is important because this is something I had to deal with in the mapper as well. And we can also offer this as a separate solution, because one of the big problems is when you have something like either the mapper or the delay that can generate multiple notes on or multiple notes off, this is something that we probably need a fix for. So maybe yeah, so this is probably would be a good result, and I think I already have like an inline solution inside of the mapper. Let's see if I'm right about this. So when I go to the mapper, yeah, here you go. This is something that I did that I don't love. It's right there in the mapper. I have something that I called send note off before each note on, something like that. This is not so good. What I would want is I want to have this almost separate, almost like as a composable thing, because this is something like that a lot of MIDI processors really need. Let's explain the problem. The problem is, for example, a delay. Let's say I hold C. Later on, the delay brings in that C again. And a synth might not know how to deal with that double C. What synth can handle this differently. one way to do this is to make sure that whenever a note on comes in, we also generate the correct note off for that thing immediately. The other problem is on the other side, is that we don't want the note, like let's say we did create multiple notes of the same C. We don't want the first note off of those to also close the second one, probably, because that would just close the sound too early. So this is one way I'm thinking of solving this. Let me think. Yeah, so let's do it. It might be two separate things. So let's call this duplicate note handler. Okay, so this is a duplicate note handler. Similar to a lot of things we already have, it's going to have a MIDI buffer for the output, and the process for this is going to look like this: process MIDI buffer, input or something, and then it's going to start by clearing the output, operating on the output, and then once it ends, it's going to do copy buffers from the output to the input. That would be like the basic operations of this. But then this needs to hold some state. So here's the idea. I'm going to go over all the notes to M input. Okay, first of all, if the message is note on or off, do something. Else we're just gonna push it. Message simple. So if it's not a note on, we just push it directly. That is the main thing. Now we do this extra handling. So let's first of all make sure this is added to my MIDI duplicate note handler. And I think I can probably copy a lot of this from, here it is. I have this thing called held notes. Yeah. Think about this for a second. Because here it would be good to actually handle MIDI channels, I believe. Let's think about this. So what I need two things here. One is that when a note on has been played, I need to see if it's held, if I had received that note on before. If it is, then I should be generating the note off right before that. If I got them, the other one is that when I get a note off, I need to do this like ref counted thing that I'm doing in the MIDI mapper exactly. Hopefully we'll switch the MIDI mapper to that, and then only when it's 0, then I present the I do this because if somebody pressed the note on again, then I only want to wait for the last note off for me to actually release this note. Otherwise, I keep the note alive. I think this is what it should do. And maybe while I do this, I'm going to also handle MIDI channels, which I did not do in the mapper. So basically, I can just have this as a I think this can just be an array of int. Sorry, and it's an array of int 128, and this is like 16, if I remember correctly. Let's call it held notes. Oh, but wait, do I need to? Because I might also need the velocity here, so it can be just an int, right? Also, like I also want to handle probably not all do I need this? No, because when I release this, do I need a node off velocity is my question. But when I do this, I already have a node off, right? So I can use the node off that I've received. Otherwise, I'll just generate my own node off with a 0 or something. Okay, so I'm good. So I'm good, I think. But I don't want an int here, because then it's not going to be correctly initialized. So let's do something like a struct held node state. It's going to have an int num held notes equals 0. Now I'll have correct initialization here, explicit initialization, which is important, instead of just an int, which would not have that, I believe. And then let's call it have nodes. Let's call it count. Count is a better one. Okay, so if it's a note on, if message is note on, then if first let's do o2 note num equals message get note number. So if the held notes, oh, let's also channel equals message dot get channel plus minus 1, because for some reason juice does starts with 1 here. I don't know why, it's very stupid, but I'm just gonna minus 1 here. If held notes channel.
So we're doing this so that we can avoid stuck notes? What's going on? Like, are we
stuck notes or either stuck
mismatched
notes or just double triggering? Because double triggering, as we've I don't know if you noticed this earlier when I was testing with the Whirly plugin, the Whirly plugin could handle a few double triggers, but then after a while it just wouldn't trigger. Like it just didn't. So
right.
So the problem might not be manifested as a stuck note. The problem might be manifested as a not triggered note, because the synth is going to run out of voices.
Okay.
Right? Because, like, for example, the first C is going to trigger a note, and the synth can say, well, I don't know what to do with this extra C. I'm just not going to trigger it. I'm not going to use it because it's still held. So
it's not just for reference counting?
It is. Well, it is a reference counting, but also just even the initial double triggering could cause a problem unless we trigger a note off there.
Okay.
Okay, so if the held notes blah 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 dot count is while I'm here, let's just store this because I'm going to use this in a million places. Let's call this o2 state or count. So I'm going to store this, and then if the count is bigger than 0, so if this note is held, then we're also is this going to be that count? Then we're first going to add note off equals message. Did I write this? Didn't I write this as a helper? I didn't. Okay, so let's do this right now. Let's do MIDI message to note off const MIDI message then return MIDI message no accept. Then return MIDI message, note off, with M, get channel, M, get note number and velocity. So just use, I can just use this, I can either use death velocity or use 0. That's another way. So note validator. Yeah, this is what it is. And you know, this is a note validator is interesting because when you're playing regular MIDI, like on your keyboard controller, a lot of these problems just don't exist. Your keyboard usually should prevent you from doing, you know, pressing the same note on without doing note off. But when you start to deal with algorithmic generation of MIDI, like a sequencer or a delay or arpeggiator, you run into all these edge cases of something being generated before, needs to regenerate again. Those are starting to be very common options. So this is just something that takes takes a note on and makes it a note off. So I'm going to to note off. I need to think about do I want to do the velocity here, but whatever. To note off M sample position, and only then add the original message, right? I'm just going to add 2 messages. First the off, then the on. But regardless of what happens, I also want to increase the count here. And I do that regardless of what I did, because eventually when I get the note off, which is my next thing here, else, if it's a note off, then I only want to let it generate the real note off. So then what I'm doing is I'm going to do minus count. Or let's do if count, because I could also get like an unrelated note off. I don't want to generate anything in that situation, but I want to do minus yeah, if count is bigger than 0, because again, it could be that somebody just sent me a note off out of the blue for no reason or something. So only then minus count. And then if count is 0, then send the message out. That's basically the logic here, I believe. So if all these other previous messages came in, you know, other duplicates that came in from the mapper or something, then do this. Otherwise, just ignore it, basically. Just ignore the note offs, because we know that the count is different. And if the count is below 0, if the count is 0, we're just completely going to ignore this, because we know this has not been held. Yes, I think. Let's see if that is generally the correct behavior. So duplicate note handle. Let's add a CVP for this, because it gets to be a long file. Duplicate note handler. I don't like this, just a big function, so let's make this a bit nicer. Let's do something like the minimum I can just do, first of all, let's start with something like so jam and sample pause. Okay, and let's extract this even further for things to make more sense. So let's do handle note on. Probably fine with some duplication here. Yeah, because things will make it clearer. So let's start with that. Or I can pass those, right? Like, I don't know, I guess it's fine. Handle node on. So then just handle node on. And the other one would be handle node off. I have some brackets here, something that I didn't close, blah, 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 blah. What did I forget? Okay. Right, what did I forget here? Oh, some extra brackets or something. What am I missing? This if this is not closed. This is not closed. This should never be open. This missing a semicolon, and I think this is it. Okay, we got this, we got this, and we got this. Okay, let's see if our duplicator does what it should be doing. So when we go, for example, one way to do this is we can just put it in the delay. So for example, the delay can have the delay itself can have a duplicate, not duplicates. And here we can be like duplicates process inputs. Let's see if this works. Let's see how good are we. What do you think, Thea? Did we get it? Did we not get it? Is it good? It's not good.
I just want to clarify. So we're trying to like prevent stack node-ons by retriggering and counting holds. Is that
Yes.
what's your?
Oop.
Oh.
What did I do here? Ooh.
But it was fine earlier.
I have a recursion here. Okay. Yes, but yes. So there's two problems that we wanted to solve. One is that things like delay in the mapper could generate multiple notes on the same note, right? And we wanted to make sure that if we do that, we also are going to trigger a node off before the double node on. So there's going to be, instead of the target synthesizer saying on, it's going to see on, off, on.
Oh, okay.
And that should prevent the problem of the synth just ignoring that node or just making it stuck or something. The other problem is with the node off. So we wanted to make sure that if a node off comes in while that multiple node on has been triggered, then we release it. We let it go.
So I thought it was like, okay, if it's already active, you emit a node off first, and then the new node on, and then increment the count. Is that what's happening?
Yes. So let's see what happens here. I think I blacked out on something. First, I forgot that if the count is bigger than, but I forgot that if the count is 0, we also need to just add the note because because with the note on, we want to add it no matter what.
So the expected behavior is just clean retriggers instead of piling up. Is that?
Yes, exactly. Here it is. Okay, so you can see what happens there. So now I'm going to hold a long note. See what that does. Long note. Do you hear what happens? Whenever I retriggered, like, did you hear the retrigger? You heard the new notes that happened? Right? Let's see what happens if I don't have that. Let's comment that out. So let's go to the delay and comment out the duplicates. See what happens now. So now I'm going to hold a long note. Okay, so you see, like I don't know if you can see what I'm pressing, but it's sometimes colliding. Like sometimes I'm holding a new note and it actually doesn't get triggered. My new note actually stops the previous note. So like there's all kinds of you don't see what I'm pressing on my physical keyboard, but it's like that doesn't work as clean. I think when I had this, let's see if this works as it should. This works much cleaner than the previous version, and I probably see. Okay, good. Now whenever I'm playing, I never get the new note stopping the previous note. It always gets stacked up. Yeah, I think this works as it should. You see this, right? That was something that the synth was stopping before. Like it wasn't letting it happen because there was all these like note offs that stopped other previous note ons. Yeah, I think that's good. Yeah, I think this looks good, pretty good. Okay, let's do that. The other thing I just wanted to do, okay, let's added duplicate node handler. And let's add the same thing to the MIDI mapper because I don't want to I think it's the same functionality. I don't want to rewrite. I'm basically rewriting this. Also the note mapper is better because it also takes MIDI channel. So now each is truly its own instance to the plugin. Yes, exactly. And you can, by the way, use this duplicator kind of separately. You can use this duplicator on its own, kind of unrelated to the mapper and the thing. So so what I'm going to do now is I'm going to some lovely chords there, Eyal. Thank you very much. Thank you very much. I'm glad that the chords are somehow being useful. Okay. Okay, so what I want to do is I want to see exactly how the mapper does it, because the mapper also has this like logic inlined. Held notes, note state. It's kind of almost the same thing. Map note. Yeah, it's eventually the same thing, right? Map notes reserve. Is this really doing the same thing? Can I just remove this? Like how am I using this held notes thing in the mapper? Let's take a look. Held notes. Okay, this is pretty much the same. And what else do I have here? Oh, I see, because the held notes is also the held notes is also it's not great. Don't laugh how I did this. It's too inlined. I want the held notes to eventually like, I think I'm using the held notes thing for two separate things, because I'm doing map, held notes, map notes, add. Yeah, but I probably don't need this, right? Like, I could just say that. So right now, what does map do? Oh, I think I understand what I did there. Map. I see. So get held notes. Yeah, I'll probably keep this in line for now, even though I probably should find a way to clean that up, because now this array is kind of doing two separate things. It's which is not the cleanest way to do this, in my opinion. But anyway, this should be okay for now. Now let's go back to our delay, and I want to add some features to the delay that I want to make. Right now, this delay is working with samples, and that is not great. Because first of all, samples is going to change with the sample rate. Like, we don't want that, I don't know, 40,000 samples would be a different speed and a different sample rate. I think that makes no sense. So first of all, we have to change this to work with more something like milliseconds, right? Would be a better way than samples. So let's start with that. So instead of doing sample position, what we would need is we need to work with a sample rate. So we need something like and then we'll also make it work with musical time. So instead of doing number of samples, sorry, sample delay, let's do double, delay. Our time is now going to be something like double time equals 0. And then we also need double time per sample. But we also need a prepare function which takes the double SR and that calculates the time per sample. So the time per sample is going to be SR time, so it's just 1.
So we're making it millisecond based and convert to samples at runtime? Is that?
Yes, basically yes. So what we're doing is, so the time is going to be, time for each sample is going to be 1 divided by SR. Is that correct? Yeah, it's going to be, so every sample, if we're going to have, 44, yeah, I think that's correct. So 44,100 samples. That means that whenever we get 44,000, it's going to make us 1 second, right? It's actually in seconds, by the way. We can call this delay seconds. But you can pass a fractional number in here. So it's double delay seconds. Now, so instead of doing plus sample pod, we're doing time per sample plus equals, time plus equals time per sample. If the trigger, so sample time is going to be double, let's call it trigger time or something. That would be trigger time. So if you delay, this should have the delay seconds. Time plus m times sample position multiplied by time per sample. And this should let us process this in a way that is sample rate dependent. So just to make sure, let's also add an assert here that says something like gsearch time per sample needs to be bigger than but 1000 or bigger than 0 actually. You have to call prepare before processing. Okay, we've done this, and then let's go to our example. Now our example is a bit more complicated. It's going to have a MIDI delay. Where is this? Where is our example? Beautiful example, MIDI delay. We did an additional process function here. An additional, override function here is going to be called prepare to play. this is when the host is going to call us with the correct sample rate. And what we do then is we go over delay lines or feedback lines, prepare with the sample rate. I don't care so much about this for now. So this is our prepare function. We make sure all the delays have the correct sample rate. And for the delay parameter, let's change it to something else. Instead of like having it an int, let's make this a param float. Let's make the minimum be 0 until, let's do 3 seconds. What's a good number? 4 seconds? I don't know. 3 seconds. Default is some small number. And maybe I'll make this just work with float so that to have like a cleaner interface. I don't think I need a double here until I go to internally calculate this. So delay seconds, double. Those args in the pop-up are crazy. What do you mean? Which pop-up? Which pop-up are we talking about? Okay, let's go back. Now it's nice float, float, float. Let's see if I got this to work. Let's see if this is correct. Oop. There is some warning here. I do not like warnings in my code. Oh, okay, because I'm not using this. Okay. MIDI delay comes in. Okay. Okay. Okay, now it's based on seconds. I'm kind of scared to change the sample rate now, but I think this would work with any sample rate. Kind of scared to change it a little because it might stop the stream. For the param function. Oh yeah, okay, I see what you're saying. So the juice parameter class, I think that's why I understand the question. So the juice parameter class is kind of weird, but this is just the way the juice parameter is constructed. This is like an object that has the hidden title for the parameter, and then the version number, which is kind of useless, but we'll talk about this some other time. But you need this to construct the parameter, and this is the displayed name. So for example, here I have vel reduction, which is more like an internal thing for like for my preset saving, and this is what gets shown on the UI. And the other stuff are the arguments. You can construct this some other ways, but this is like generally the convention, right? So if you look at the way how is this like this, this is the thing I'm using, right? So it's the parameter ID, name, minimum value, maximum value, default value.
Are they talking about the parameter ID plus the version number thing?
Yeah. So anyway, this is already an improvement of what we had before, because now we're not doing the delay based on samples. We're now doing like more, you know. First of all, we have fractional time delay. It's very nice. You know, I can have exactly some. Okay, let's make it shorter. I have a stuck note here from the previous feedback, probably. Hey, I have a stuck note. What do I have a stuck note here? I think I probably need to, whenever I change the number of feedbacks, to somehow release this. But this is more specific to this plugin here and not to the library. Okay, let's commit this because this is pretty good. So delay switched to using seconds instead of samples to work with any sample rate. So that's already better. That's better. Okay, one last thing we need before we will finish the stream is we want to talk about musical time, right? Okay. Yeah, like when you highlight the parameter flow type, the editor shows the full expanded arcs and just looked very verbose. You mean this thing? This thing. Parameter ID, string-like identifier, int version hint. I wonder which one did I see? Was it this one? This one? Maybe this one. I'm not sure. I don't even notice that I do these things, so. Okay. Okay, so. Okay, so we've done, now we have the MIDI delay, and let's talk about the let's talk about doing some musical time in here. So yeah, so I guess one way is we can make this almost like as a separate helper. So there's a few ways to do this. One is we can grab like some musical time position based on the BPM, and that can actually be a complete like helper if we do it like this. So if we just want to take you know, just say that, for example, I want a quarter note and I want this quarter note to be based on the BPM. That's going to be a useful thing here. So we can just do a helper here in the delay. Let's call this something like const. Sure, we can const this. So one thing we can do is we can do something like double get time 4, and we need the double musical time, double BPM, I think, and then double sample rate. I think that's what we need to calculate those, right? So then the math, let's call it get delay. Get delay time for musical time, BPM, SR, and I'll even add a helper that does this for the audio processor. Yeah, so this should do something like this. So we need So here's I always have this function kind of prepared. So we'll just look at where I have this function already written, because I already confused that math. Let's see where I have this code. Okay, so here those functions are. Okay, so the main thing, so the first one I need, let's switch this to, go to the source file. So first thing is we need to get the sample per beat. Oh, do I even need the samples here? I might not even need the sample stuff, right? Because I can just do, yeah, I can just do sample rate. Yeah, so I can just do SR times 60 to get 1 minute, and then divided by the tempo. And then I need to just multiply this by the musical time. And I think that's it. Because the musical time would be like 1 would be 1/4. Yeah, and I don't even need this. Okay, this is basically the math, I believe. So return get delay time 4. So I think that's basically the function that is needed. This should probably be a no except, but it matters. Okay. Hey, could you turn your mic volume up a bit? I can barely hear it on max. Ooh, that's interesting. So is my volume low? Is my is my volume low, or is it because I'm just talking to myself? Because I can definitely turn it up.
Yeah.
Yeah.
It's slightly low, but.
Oh, that sucks. Okay, well, I'm happy to bring it up. Too bad I didn't know at the beginning of the stream.
No, I mean, you're fine. It's just when you started kind of getting into it.
Is that better now? Is it better now? Is it higher? Looks like I can do even a bit more. Hey.
Yeah, you're fine.
All right. Okay. Sorry for the lack of correct calibration here. Hopefully the rest of the stream is okay-ish. Okay, so we have this beautiful function, get delay time 4. And then let's add one for the audio processor. So double, missing semicolon here, double get delay time 4. And this should give me the processor, and then I think the processor should be okay with getting the sample, right? And then double musical time. And I probably should do something like let's call it fallback BPM, because I might not have it, so just to have something. Okay, so now O2 playhead equals processor dot get playhead. So let's have this function called get BPM from the processor, and fallback, because the fallback might be needed. So auto ph equals if processor dot get playhead. And then if no, it's ph get position. Is that the more? I never forget if that's the modern one or not. Yes. Okay. So if O2 pause equal, there's a lot of optionals here. If the position is get position, then if photo BPM equals pause get BPM, then return BPM. And unless we have all of these, we're going to return the fallback. So all this would do is this would just be get delay time for processor, get BPM, processor, fallback, musical time. And processor dot get sample rate. Oh, do I need a sample rate here? What do I even need the sample rate here? I don't care about the sample rate. No. I just need musical time and BPM. There's no need for this. I keep thinking about all the pair sample stuff that I'm usually doing, but I don't need that at all. So this would just be this musical time BPM. Blah 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 blah. No,
I think it's just when you're talking kind of to yourself, that's when the volume.
Oh, so maybe I get too much away from the microphone. I should just keep the microphone.
I think that's what's happening.
Oh yeah, okay, and I can also do this like this. All right, okay. So not get default delay preset, but get delay time for musical time and the BPM. Good. Return this, okay. And now I should be able to just, this can just be a constant, right? Const. Yeah, let's make this a const. Okay, so why did I do all of this? I did this because now I can go, like, let's say that I want to have a musical time element, not just a fixed time. Let's add those. This is just one of the things you add a lot in different delay formats. So this delay parameter is going to be fixed delay, but let's add musical delay. So I'm going to add two more parameters. One is going to be param bool. I'm going to call this, let's call it param choice. It's better, param choice. Let's call it musical mode. Musical time equals new param choice. Musical time 1. Musical time. So the question is, I just joined in. What are you creating? So we're creating a library that we're starting to use in the previous stream, which does all kinds of MIDI mapping. But in this particular one, we actually created a MIDI delay. So we created a MIDI delay and all kinds of utilities to do with this MIDI delay. We're going to play it in a couple of seconds because the feature I'm adding just now is so that the MIDI delay would not just be based on fixed time, like 1 second, half a second. It's also going to be based on a musical time, like quarter note, half note, triplets, etc. So I'm going to enable this musical time, and let's do I need to get the choices. So let's do something like a choose string array get musical time choices, and this one is going to be linear musical, or maybe a better way would just be like time and tempo or something. Time tempo. So let's get these choices, and the default is going to be 0. So this is the musical time parameter, or let's call it musical time choice. And then let's add another one called, similar to this another choice parameter. Let's call it musical time duration. Oh, so maybe I'm not gonna, let's call this not musical time. Let's call it time choice. Time choice, and this would be time.
So we're adding like a mode switch between free time and tempo sync delay, is that?
Yes, exactly. So we can have both. So this would give us some musical time choices. This should be get time choices. And musical time choices would be more something like, you know, quarter note, and then I'm not going to do all of them, but let's do, you know, 8 notes, 16th notes, and let's also do, you know, half would be good. And let's do some fun ones just for the sake of it. Let's do, you know, 8 triplets. You can also do dotted or something. Let's do 8 triplet, and let's do 8 dotted, just so that I'll have some amount of options here. So we're going to start with that, and then let's and this would have these musical time choices. Good. Let's add those to the thing. So I got the delay, and I got the, let's make the first one be time choice. Okay. And then let's make a nice helper function that's called float get delay time. And then this would do if time choice get index is 0, then return the delay param get, so just return the regular time. And otherwise, let's switch on the musical time durations get index. It's gonna be kind of horrible, but I'm just gonna hand write this. Case 0 return 0.5. Case 1 return 1. Case 2 return, sorry, it's not provided, this is 2.0. Return 0.5. Case 3 return 0.25. Case 4 return it's a triplet, so this is going to be like 1 divided by 3, so 3 notes for a quarter note. And case 5 is going to be dotted, so that means it's going to be 0.75, right? I think that's what an 8th dotted is going to be, right? Do I know what I'm talking about? Yeah, it's an 8 note plus another 16th note. I think that's correct. And otherwise, just return whatever, some fallback or something. Okay, so this is my get delay time function. It's kind of raw, but this is like more of like an example function. So but instead, I don't need these numbers. I need the function that I already wrote. So let's make a another helper function called float get musical delay time. It should also be const probably. This would do the switch case. And this function would just do time equals get musical delay time, then return MIDI MIDI get delay time for this and time. Float. So the question is, couldn't you just do a lookup table instead of the switch? 100% this should be a lookup table. I'm just lazy. So this should be a lookup table. If you've seen some of my previous tutorials, this belongs in a lookup table. I'm just very lazy. But if this would go into the library, I would 100% use a lookup table here. So would also make changing things later way smoother when readable. Yeah, I 100% agree. And this is why, when I'm writing these examples, I'm sometimes being pretty lazy and not very good. But this should be a lookup table where the string, for example, is allocated right next to the time. So what Tomba is saying is 100% correct here. And so usually what I'm doing is sometimes I'm just writing, when I'm writing the example, I'm just writing the fastest way to test the feature. And then once the feature is working, I'm going to clean it up. That's how I've done it in other things in this series as well. Like I'll write something quick and then check that it works, and then do the correct thing, which is the lookup table 100%. Anything to get it first draft out. Yeah, and it's even not a first draft out. It's also a matter of like testing that I'm not missing anything basic about the feature. Like maybe I'll do this and I'm like, oh my God, I'm missing this implementation of the thing completely. Something is completely, and then I clean it up. So I like to do this to kind of get the mechanics across. But yes, we will do the lookup table momentarily. This was a very correct thing to do. Like if I had reviewed this code, I would be saying immediately, hey, where's the lookup table? This would be very true. So let's just start with that, and blah 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 blah. So instead of doing this when I'm in my process block, delay time would be get delay time. Let's see if this works. I might need to check it in a okay, let's see what our plugin looks like. Okay, so first of all, we see we have musical time here, and I have time and tempo. So when I'm in time, only this affects. Oh, that's interesting. Look, there's a bug in the delay, unrelated. So it looks like if a note, looks like I have a situation where the note off was never triggered. I need to fix that. Yeah, when I make the delay time shorter. Huh, that's interesting. That is interesting. Okay, so first of all, let's get out of here. Let's come back in. Okay, let's check the musical time option, and then I'm going to fix the delay and make it work. So let's go to tempo, and now this should be impacting this. So this should be 8 notes. Let's do 60 notes. Let's do 8 triplets. Okay, and let's do 8 dotted. I think this works pretty well. I could probably test it in a host so that I get more. But I have a BPM here in Plugin Buddy, so I can change that. So let's switch to 8 notes. Right now it's faster. Now it's slower. I still have the issue of stuck notes I need to fix. But let's start with that. So let's do let's commit this instead. Added initial musical time option for the demo. Great. Let's now see exactly what my problem was with when I think that the problem was when the delay time got shorter. So let's see if I can understand what happened there. To try to understand, I'm going to place my, so the problem was, let's see if we can reproduce it. Let's switch to time and not tempo. So the problem was I started with a long time. So long time, then I'm going to make it shorter. Is that what happened? Or the problem was it was a long note. So let's do a long note and stop. Was it because I reduced it to 0? I wonder if it's a problem because of the multiple feedbacks. Let's see if this is gonna if this would only happen if this was gonna happen the same way if I have one feedback. So if I have one feedback, yeah, it seems like this could still happen. So there's a chance for a stuck note here. So let's look at my duplicate note handler. It might have a bug in it. So let's go to duplicate note handler. Duplicate note handler, blah, 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 blah. So note off, I'll look at the count. If the count, I wonder if it ever happened when the count is, and maybe I'm just ignoring something that's wrong here. Like, let's just add in a search here just to see if this could actually happen. Okay. Okay, so it looks like this could happen. Let's see what does this happen. So is this because yeah, I guess because of the delay. So maybe what I should be doing is that if the count is already 0, yeah, I should also handle the count of 0 here because I don't Is this correct? Yeah, because I think what happens here, because there's multiple, yeah, like it's possible the note off would come in without a note on or something stored, right? I think that's a problem. Let's see if I understand this correctly. So, get the MIDI delay here. No. No, there's a problem here on the note on. This really shouldn't happen. Like let's keep the assert back here. Let's see what I'm doing on the note on again.
So it's like if the note offs are delayed or duplicated while parameters change, is it like a final note off is missed? Is that what's happening? What's going on?
Yeah, it seems like there could be issues here when. Yeah, it seems like there are issues here when the notes off never gets triggered when I'm changing the delay settings. I'm trying to figure out why. So let's see. And this happens even with linear time. So it's not just a musical time thing. There's a question here. Hey, web mobile engineer here. Was wondering if Rust is also starting to show up in the plugin space as well. I've seen a couple of people trying to write plugins in Rust. To my knowledge, none of it is released. Maybe somebody has one thing that's like released. I know there's a couple of people that tried that. I think technically you should be able to do that. Like it's, Rust is a low-level language. You should be able to write similar things. But I think the ecosystem is not really there. Like you're going to have to interface with a lot of like C and C++ libraries, and it's kind of like defeats the point of using Rust if you have to work with all these libraries. But there are a couple of attempts to make a plugin framework. There are attempts to do, wrappers around stuff. So yeah, it's technically a viable language to use. Yeah, I mean, you should be able to do that. I'm not, personally, I'm not so much in like the language space. Like I think that, like I don't think it really matters. Like I think people give these qualities to programming languages that kind of don't matter. Like to me, it's all about the libraries and not the language. So I'm like, okay, if somebody wrote a framework that is, like plugin ready, similar to Juice, then I would, I would switch to using Rust if that plugin framework is better and well tested and more durable. Like I don't care so much about the language. I would, for example, I love Swift. I think Swift is an incredible language. If Swift would have a great, cross-platform solution for plugins, I would use that. Like I feel like it's kind of like it's not really interesting for me. Like there are languages that are just not technically suitable to make plugins. Like Java would be hard or something, or Python would be hard to make a plugin because it's not low level enough. But Rust is very technically suitable language to make this. So I'm like, but why would I do all this work? Like, why would I start to write wrap? Like, for example, I'm using Juice, or I'm using like the VST3 SDK, or I'm going to use some, DSP library. Like, why would I start writing wrappers around all these libraries to get something happening? Like, I feel like it's it's not a good, spend of my time. Like, do I like like, do I think the syntax of Rust is so much better to switch the whole ecosystem? No, I think it's kind of the same. I think C++ does some things a little better in terms of the syntax. I think Rust does some things better. The borrow checker in Rust is good, but the templates in C++ is better. I don't know. Like, I'm like, okay, do I really care so much about which language? I mean, I don't know. Maybe if I had other projects that I would use for Rust, like maybe if I had a big Rust library, I'd be like, okay, I want these utilities in my project. Let's get those in. But I don't. I have them already in C++. And other people also have them in C++. So I feel like it would be like counterproductive to work there unless you are an enthusiast. So the question: someone has to make the first move, though. So people have. There are people that try to make plugins in Rust. If you go to the Audio Programmer Discord, there's a couple of people there trying to make it happen. And again, it's technically correct. There's no problem. The language is suitable. But then you're like, okay, am I going to write wrappers around all the DSP libraries and all the plugin wrapper libraries and whatever? Like is this interesting work to you? If it is, then do it. Like I find that to be very boring work. Like it's just it's just like for example, there's a lot of question of like, there's a lot of libraries written in C, right? And I don't like to write C, but I do like to use those libraries that are written in C. So I'm like, I feel like it would be very wasteful for me to like say, oh, I love C++ better than C, so I'm going to rewrite all these other libraries in C++, or wrappers around all these libraries. Like I want to use SDL. I'm going to start wrapping the entire SDL in C++. I don't want to, because SDL is great and it's in C and I can just call it, right? Like it would be kind of wasteful for me to create a whole new ecosystem just so that the calls to functions would look how I like them to look. I feel like it's sure. Like I see why people are interested in it, but it's not very exciting for me. Also, personally, I don't think Rust is better than C++. I think it's one of these. It has some things that are better, like the pattern matching in Rust is awesome. Like I wish C++ had that. Cargo is better than what C++ has for like standard package management, so that's good. But also, compile times for Rust are really horrible, so you're kind of like bad. The IDEs are not very good, so you're losing out on tools. It's kind of like, you have this like big trade-off of all these like pros and cons, and I'm like, and eventually, is this solving any kind of problem? Is the borrow checker in your project saving you from like month of work? Probably not. It's like a very, it solves a particular thing. I don't know how to explain it. It's more like I feel like all these decision makings are if I would be like learning Rust anyway, and I'd be like, okay, I want to learn how to do everything in Rust. It's important to me. I want to get better in it. Then I would make the plugins in Rust because I'm like, okay, let's learn how this works. Let's see. Or I would want to, I see that with people trying to make game engines in Rust. You could, it's possible, but you would be like distancing yourself from the rest of the community. Like let's say you would be running into trouble. Are you going to talk and you want to ask another engineer, how did you solve this? They've solved it in C++ because that's what the gaming industry is using. So you'll be on your own path for not a lot of benefit. I don't know. I feel like all of this language stuff is just, it's kind of, it's kind of alien to me. Swift, for example, I like because like if you're working in that space, in like the Apple space, it's a really nice language with amazing libraries. Like you want to make an iOS app, everything is really ready for you. Like it's it's much nicer than writing it in C or C++. It's really like a better experience, and everyone else are also writing it in Swift, so you have people to ask, you have a community. It's great. If maybe it's the same for other domains in Rust, like maybe if you're writing like web services, or something. So, yeah. Yeah, I really wonder how they're going to scale the Rust compiler for the Linux projects. I have no idea, but that's really beyond me. Like the Linux kernel things, like those are really, even now, like it's not like Linux is using CMake or something like high level. Linux kernel is using like a weird build system with a bunch of weird scripts and custom make files, and like that whole the way they've set up their system is very particular to how they worked. So I don't know how they're gonna solve these kind of problems. Guitar Tricks asks, "Wow, how long have you been live?" I've been live for 3 hours. It's not even my longest one. I've done longer live streams, I want to say.
Time for sleep.
I was just wondering how it's proliferating. I have no idea. This one says the constant breaking changes in Swift is a bit terrible, though. I mean, I don't know. I haven't gotten so deeply into that, but I would say that it's something that is interesting when you think of like API design. Do you want an API that's stable, or do you want an API that's modern? And I'm usually on the side that says make things more modern and break stuff and kind of make developers get used to it, because that's how we move forward and we're not stuck with all this like legacy. But I understand the other side of this. There's something that people love about like the Windows APIs is that you might have been writing a Windows program in 1997 and it's still going to compile and run today, and that's great. But Apple have this other way to look at things, which is also really good. Like if you're modernizing yourself, you're going to get all the new features and you're going to be safer, and things are just going to be better supported on multiple hardware. It's not going to be like, so I don't know. I feel like there's pros and cons to this from an, if you're designing a language or a library. Next question is, have you ever tried Zig? I've not tried Zig, but I've seen videos of it. It looks pretty cool, to be honest. Like, it looks like a cool language. But again, I don't see the reason to switch a language for a language. Like, I'm not that interested in languages, unless there was something that I couldn't do. Like if you told me, hey, look, there's this thing that you cannot do in C++. It's not possible. And I'll be like, okay, I gotta switch, because or if you told me there's this library that's so good, and if you use this, it's a framework, it solves all your problems, you gotta switch. I'm like, like if you're writing an iOS app and you want to use all the Apple stuff, like this, it solves like a big problem. But I don't see the big need of solving problems that are already solved in a slightly different way. Like I don't see Rust solving a problem that C++ is not solving. I see it solving the exact same problems with slightly different syntax and compiler that it's a little bit more strict. And again, I see the value in developing languages. I'm just not so excited about something doing the exact same thing, but with a compiler that tells you that you cannot share references, or something, or with I don't know. Carl, my friend Carl, is asking, Thea, are you just here to keep him on track?
I'm here to clarify things. Hi, Carl. Sometimes, like, when you start coding and then you kind of get lost and you don't know what you're actually doing. Like, people watching actually have no idea what's happening. So I'm just here to clarify.
Yeah.
This whole thing started because of my project.
Yeah, it's an interesting discussion, though. So I like these kind of discussions, because some of these languages do show like real benefits. Like sometimes you use something like, like if, for example, if you make a project and you use Python, like there are a lot of disadvantages to using Python, but there are some huge advantages to using Python. Like Python has all these amazing libraries and machine learning libraries and graphics libraries and like web server libraries, and like it's amazing. It's like this huge thing Whereas with all this amazing echo, so if somebody asks me, hey, would you make this project on Python? I'm like, there is a reason to do this, right? Even though Python is higher level and has some performance issues and all that. The JavaScript has this amazing benefit of running in the browser natively. It's great. Also, it has all these libraries for web things. Like, it's great. It's such a great language to do things that are good for this language. So I'm like, okay, I can see the reason to choose this. It's hard for me to like get so obsessed about the reason to use, Jai or Zig or Rust over C++. Like, I feel like it's those languages are the same. They're all the same. Okay, so somebody hates the syntax of of functions, so they like a better syntax with an arrow before and the word fn, and they like better that the compiler is telling them that they share a reference when they shouldn't. Okay, sure, that's an advantage. It's some advantage. I don't see any of these like being big problems. So the question is, can I make the code or screen larger? Yeah, I should be able to do that. You know what? Honestly, why am I using this? I'm trying to zoom once in a while so that it's even bigger. I wish can I make this thing be more zoomed? Am I on the biggest zoom? I am on the biggest zoom here, but I should be able to zoom once in a while to show things. This is a question here. Experience with Go. I've never used Go. I know a lot of people use Go for like backend services. It's supposed to be great for that. I've never used it, but I hear really good things about it. That it's really great for all the. I mean, I have written quite a few web backend endpoints, but probably not as much as people who are professionals at it. So I think I'm probably not a good domain expert to answer about Go. Like, I don't know if are people doing other things in Go other than web servers and this kind of functions. I think this is mostly what it's used for. It's hard to say. Maybe it's a good question to ask somebody who's more of a has doing more of that than I do. Anyway, here's what I was trying to do, and what I want to do is I'm going to place a log here to see exactly what happened with my delays. Blah 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 blah, delay process, and I should have something like a log. How did I call that thing? Log. So I want to write a log here and see what this does. Okay. Okay, on off. Let's go now. On off. That looks good. On off. Yeah, all this stuff looks good. Let's see what happens if I have. Yep. On off. So, okay, so what could happen here? Okay, I'm starting to understand what happened here. If I do this, then if I change the time to be lower, I think what could happen is the note off could come in before the note on. Yeah, I think that's what happens here. I think if I make the delay time shorter, I think that's probably what happens there. Right? That's why it's throws the assert. I think the problem is if I make the delay time shorter while it's being played, it's possible that the notes the note off would come in very quickly, but it would come out of order without that note off. Like the note on, here's what I think I understand what happens. The note on comes in with a long, I store it with a long delay, and then when note off comes in, yeah, so I think what I need to do something a bit more heavyweight here in delay. I think what I need to do here, because right now when I'm storing the note, I'm holding the time, and if I'm changing the delay time, okay, so I think I probably need to do something else here. Let's think of how I'm going to do this. What I could do is I can store the time where something has been played. I like that. So yeah, so what I can do is I can just store I will not do this. I will store the time when it was triggered, and then I'm going to figure out, yeah, I think this is better. I think then I would do if message is not triggered, then let's have another if here. Then target time equals to message dot trigger time plus delay seconds. And then if target time is less or equals to time, then do this. Right? Basically what I've done is so that if the delay time is changing, that means I'm going to look at all the delayed notes with the, with whatever the setting is. Like I'm not going to store them with a delay for the future and then kind of wait to the future. Now I'm basically recalculating the delay every single time. So let's see if I'm correct in this. So if I like this logic correctly. Oh, look at this, beautiful. No stuck notes and no asserts as well. Beautiful. Thea, do you understand the problem that I was trying to solve? Or no? I don't know if I was talking to myself too much here. Let's see.
Okay, so
it's really beautiful stuff. I can make some really nice music. I think it's gonna be a good plugin,
yeah, Bill's friend will be happy.
Oh, I can make some really nice stuff with that. I'm kind of surprised at how well this works.
The bug happened because node off and node off were delayed independently? Is that what it was? So if the node off arrives earlier in the block.
Yeah, so the problem was, let me remove this log now because I don't need it. So here's what the bug was. Oh, thank you. The bug, let's see if I'm gonna switch to this for a second. Okay, so the bug was when I was storing, like a note would come in from the user, right? And I would also know at that moment what is the intended delay time, like 1 second, right? So what I would do is I would store a target time for the note. I would say this note is to be played 1 second in the future, right? The problem with MIDI is, very interesting because we get separate note on and off events, right? So here's what could happen. It would happen, and it could only happen if I was playing while I was moving the slider, at the same time. So what would happen is the note on would come in and be stored with a delay time, let's say 1 second in the future. And then I would move the slider to some short time, right? Like let's say 0 seconds in the future. And then I would very quickly let go of the note. What would happen is the note off would be triggered before the note on, because the note on still was scheduled for 1 second in the future. But when the note off came in, it came in with a function that says 0 seconds delay. So trigger right away. Right? So the order of events, even though I played them in the correct order, I did note on and then off. What happened in the output was that the off came in first, and then the note on came in second, and then we got a stuck note. So here's how I fixed it. What I did was, instead of storing in my little delay buffer, instead of storing the notes that are like the absolute time when the notes are to be scheduled, like 1 second in the future, I wrote down the time where they have been where they started, basically. So I said the note started at 5 seconds in, but I didn't. But when I did it, I didn't even register how long the delay time is. In my next loop, I'm saying, well, the note was. I know now in this processing function that the time is 1 second, and the note has been triggered, in 5 seconds. Then I know that until it's 6 seconds, it's time for 6 seconds. There's no need to trigger that note. But what it meant is that the notes always, within the same function, the notes always get processed in the same logical order. So if we look at our delay buffer, or in this case, just a vector of scheduled notes, that vector would say something like, here's a note from 5 seconds. Here's a note from 6, or is a note off for 6 seconds. Here's a note on for 7 seconds. It would be in order. And within that function, I could just add the delay time to it to see if it's already time to process. So the calculation then became ordered. It wasn't all these, because these adds, that the add of the trigger time along with the delay time before would happen in separate places for separate notes.
Okay. So previously it was like scheduled to fire before its corresponding note on.
Well, it wasn't necessarily scheduling before, but it could schedule before if the order of events was play a note, schedule it for later, then let go of the note, schedule it for now, right? So the note off would be now, and the note on would be later.
So it was breaking the hell note count. That.
Yes, but it wasn't even getting to the ref count part. It was just breaking the assert happened in the.
Oh, right.
In the ref count part, but the bug was happening before. The bug was in just the way the delay was processing. So the delay was processing things and I think it's much. Also, what I did now is better for another reason. It means that here's another reason why it's better. A feature, not just a bug. So let's run this and see a feature that would make it cool. Because right now I'm recalculating the target delay notes every time I'm running the process function, right? Here's what it means. It means that I can, let's say I have a long delay. Let's have a lot of feedback here. Right, this is a long, right? It's a long feedback. Let's make it even longer.
Can you make that bigger? Like right now, it's tiny.
Like more time or louder?
No, I mean the code editor.
Oh yeah. So, yeah. Okay. So let's even zoom on. Here. This is what we're doing. So, right. So this is just a long delay, and you can see it. Reducing the velocity very slowly. Right. That's good. Now, what I could do now, which I could not do in the past, is I can make this delay time shorter while this delay has been triggered. So I'm going to start triggering this, and then I'm going to move the delay time down. So you see it becomes faster. By the way, I think the these clicks are because of the synth, this instrument that I'm using. So I think I might need to change buffer size a little bit. The sampler doesn't always like low buffer sizes. This whirly synth that I'm using. Anyway, so now I can start with a longer time. Right? See how that works? Let's give it a bit more of a reduction. Cool, right?
Yeah, it's
yes,
really cool.
No, right?
Yes,
okay.
I'm definitely using it.
Okay, so even if you're not doing this recursive, feedback thing, I think that is the ideal way where this should work, right? That's how it works in an analog delay as well. Like if we had an analog delay, then the analog delay would be, like if you, as you move the things faster, the repeats kind of come back to you, right? They all push itself back because we just keep scanning faster, which I didn't do before. Before I wasn't scanning any faster while I was moving the slider. So that itself could be a model, like process delayed notes in runtime. Yeah, exactly. So this is, but this is the let's call it I think the idea we have so far. I think this is not bad, right? What do you think about what we have so far? Is this usable for you?
Yeah, it's definitely more sophisticated than what I had.
Yeah. So now you should be able to look at this example, for what you're doing. And just, you don't even need all the feedback stuff, right? Like you can just do one, and you don't even need the special delay processor stuff, right? Because you might not need that.
But then, I think he wanted those features probably for version 2, but
yeah. So you could this if you wanted to, right? And you can also make, I don't know. We'll think about what other features, but so let's start with that. Let's go to commit this. And fixed delay time issue when the notes on and off could come out of the delay out of order. Okay, I think this is pretty good for the stream today. Well, does anybody have any other questions before we wrap this out? Wrap this in. How do you speak English?
Wrap this out. Is anybody still around?
There are definitely some people around.
Okay, everybody's passed out. I don't know how you can do 3-hour stream. It's pretty insane.
Good question. I don't know how I can do this, but I guess we did it. All right. So thank you, Thea, and thank you everyone for watching. Everything we just did today is on my GitHub, so definitely take that. It's very possible that I'll make this MIDI plugin included in Plugin Buddy. I think it might be really useful for that. So, Plugin Buddy is what I've used. Like, it's like a plugin host that is free, and it's great for plugin development, but it's also great if you just want to come up with a few MIDI effects and an instrument and just play. So definitely get Plugin Buddy for free on the Modalix website. We had a new update for this come out. I want to say, was it a couple of weeks ago? There's an update that hosts AU plugins and has some other new features. So try that. I'm going to do probably a separate video on Plugin Buddy on the new features, because I think it's cool and it's one of the things that I use all the time. I use it for my own development work, but I use it because I want to play piano and I want to use my piano. I want to use Ivory, or I want to use the Swirlitzer plugin, or I want to use Beat Scholar or something. Anyway, hopefully this is useful. Thank you, Martin. Thank you for everyone who came down. And see you all soon.
Happy holidays.